Alright, welcome. This is the 7.5 Ready Set Go homework solutions. Here you have the ready part. It says for each set of lines using the point on the line to determine which lines is the image and which one is the pre-image. Write the image by the image line and pre-image by the original line. Then define the transformation that was used to create the image. Finally, find the equation for each line. Okay, so you have number 1 right here. Okay. Right, and we could do that right here. So the original one is the N and the M, so that one we can call that as the pre-image, right? And the new one we could make that red, right? That's the N prime and the M prime. That would be the image. Good. Right. Again, that is your image and that is your pre-image. Alright, describe the transformation from here. From the pre-image to the image, it went up 4 spots up. That is why it's x plus 0, y plus 4. Nothing happens left and right. That's why it's plus 0. And it is plus 4 because it's going up vertically 4. The equation for the pre-image here, the slope here is up 1 across 3. So the change of the y was the 1, changed by the x was 3. So okay. The y-intercept here is -2, -1, -2. That is correct as the right slope. Up 1 across 3. What is for the image? The image right here, it has the same slope of going up 1. That is your change of y. Then across 3, which is your change of x. Plus 2, because the y-intercept here is 2. Good. You have number 2 here. Oops. Let me give you that. Alright, so it looks like that. Alright, so let's just take a look. The original is L and M, so we can call that the pre-image. And the new one is the image. There you go. Grabbing that. That is how it would look like. There you go. That is the pre-image and that is the image. Okay. How am I going from the pre-image to the image? It is sliding to the right. It's having a translation to the right. So it's add 3. It's going over 3 spots. Look at the M to the M prime. 1, 2, 3. Okay. That's the general rule. It's x plus 3, y plus 0. The equation for the pre-image here, you have the slope is -3 because it goes down on the y. 1, 2, 3 across 1. That is why the slope is -3 over 1. The y-intercept here is 4. Right there. The equation for the image, right after the translation, it is y equals to -3 over 1x plus 15. Right? Because if you apply it, if you go up, the y-intercept is right there. Okay, there you go. Next one. Right, this one is going to be hard because I have it on the side, so I can text art this if you want. So the original is going to be in red. I'm going to call that the pre-image. Okay, the pre-image would be right here, because that is the P and O. There's no prime. Then the new one would be word of art blue. Let's make that image. And that is the new one right there. That's the image. In that process, describe the translation. Right? It shift over. Okay. The slope here is up 2, 1, 2 across 3. 1, 2, 3. That is correct. Okay. The y-intercept for the first one is, the translation is, hold on, 1, 2, 3, 4, 5. It's subtract 5. Okay. Subtract 5. Yep. Okay. Because do you see how it P to P prime you subtract 1, 2, 3, 4, 5 from the X, right? That's the description of the transformation. A translation 5 units to the left. The pre-image here is y equals 2 over 3x minus 2. The minus 2 is the y-intercept right here. The slope is 2 over 3. 2 is the change in the y, and 3 is the change in the x. Right? Next one, the equation for the image. The slope remains the same, up 2, to the right 3, but the y-intercept is changed. It's like 1.5-ish. Right? Next, it says write an equation for a line with the same slope that goes through the origin. Right? Same slope means the slope is the same as 2 over 3. The fact that it goes through the origin, the point here is 0. So you plug it into the equation of y equals mx plus b. You get y equals 2/3 x plus 0. 5. You're going to write an equation for a line perpendicular to these through the point of O prime. O prime is right here. Did I get O prime wrong? O prime is actually negative 2. Right? O prime's right here. Negative 2, 0. Alright? So, perpendicular slope, you flip this, then change the sign. So the 3 goes on top, the 2 goes on bottom, and it's a positive, it becomes negative. That is the perpendicular slope. The point here is negative 2, 0, so that means I have to change this. Hold on. That is still a 0. This is still going to be a what? Negative 2. So when this multiplies here, you get you get positive 3. Yep, because negative 3 over 2 times 2 would be positive 3. Okay, nothing here because it's a minus 0. So this would be the equation that is perpendicular to this image right here. Okay, it goes down this line basically. I think I could draw it for you. It looks roughly like this. Right? Negative 3. Ooh, wait, the slope 3, but the y-intercept is 3, so it should be up. Wait, but that is going through the point, hold on, but that is going through the point negative 2, comma 0, perpendicular slope, which is 3 over 2, goes down 2, 3 across 2. The perpendicular slope, you want to go through O prime. The perpendicular slope going through O prime should look like that. Right, give me a second here. Right? Yep, that's right. This would be right. Oops, sorry. This would be plus. That's what I got it. It's plus 3. Yeah, it's a minus. Let me show you. You see how it's a minus, minus? It's subtract. Alright? That's why together this becomes a positive. Okay? Then you distribute the negative over. This becomes a negative. That's why. Because here the point should have been, it's off a little bit, but it should be negative 3, so it's like, looks something like that. That makes sense, right? That's why you should always graph it for it to make make sense here. Okay. Wait, that's how it should look like. Do you see how it should cross through that point here of negative 3, negative 1, negative 2, negative 3. Perfect. This is called the point sloped equation. It's y minus y1 equals m parentheses x minus x1. Alright? Next, after working with these equations and seeing the transformation on the coordinate graph, it is good timing to consider similar work based on the table. Match the table values below with the proper function. Here, we saw that it's going from 16, 14, 12, and 0. You saw that it is a decreasing in an arithmetic sequence by 2. Right? So, I have negative 2 parentheses x minus 1 close parentheses plus 8. Okay? 2 here, you saw that it is a minus 2. Okay, for the x. And that is when it's also going from 14, 12, 10 to 8. Right? it's plus 8, and then negative 2 is out in front. Next one, same thing, but it goes from 12, 10, 8, and 6. Okay? The only difference for this one is that it is an x minus 1 out in front. Okay, hold on. Let me double check that, because I think I got... This should be A. Good. And B was negative 2. Good. And this one was A. Hold on. B... Oops, yes, I typed this in wrong. This was actually supposed to be A, so that was, and one is B, which is, one of them is a plus 12. This is a plus 12. Yeah, that makes sense. Okay, because of the 12 right there. Good. So this was B, C, A. Oh, A was 8. B was 12. This was 12. The first term here is 12. The first term here is... Hold on. 2 is C. The first term, yep. Because this still becomes 12. The first term here is 8. Good. Twice this plus that. That does 4 becomes E, which is 8. Good. And here the first term is 4. Good. It becomes negative 2 parentheses x plus 1 plus 10. These are all just chart formats of this. Okay. Alright. Alright. Next one. The set part. Using congruent triangles. Right? In each problem below, there are some true statements listed. For these statements are conjectures, which are guesses that might be true. Use the given statement and conjecture statement to create an argument that justifies the conjecture. Okay? Look, I know some of you are like, Mr.S, you never really explained this. Go back to the first module where we made charts. That's how I got these. Okay? These aren't, these comes from arithmetic sequences. Right? Or you could just use point slope to get here. Okay? If you want more detail on this, just come back and I can explain it to you. Okay? Alright. Ask in class or after school. Okay? Alright. Let's look at 7. Okay? It says M is the midpoint of line DB, and we have this angle's true. ABD is congruent to DBC. Okay, and also DB is equal to DC. So that's how I got D. So I have these two sides because M is the midpoint. It cuts two equal segments. This, which is 2 hash, this is 2 hash. The angle comes from the information which was given, and DC and did I type that in wrong? Hold on. DC, what is it? Hold on. This is AB. AB is equal to CD. Yeah, I did type this in wrong. AB is equal to DC. That's how I got that side. So side, angle, side, right there. The two triangles are congruent by side, angle, side. Okay? The fact that the triangle is congruent, the parts are congruent. Therefore, angle A has to be congruent to angle C by CPCT. Congruent parts means congruent triangles, or vice versa. Congruent triangles have congruent parts. 8. Okay, true statement. Angle KJL is congruent to angle KJM. KJL, that's that angle, is equal to K, or congruent to KJM. Angle congruent. JL is congruent to JM. Congruent there. The two triangles are congruent by SAS. Side, angle, side. Again, JK is shared, right? That's why it's congruent. Therefore, we say angle KJL is congruent to angle KJM by CPCT. Congruent parts, congruent triangles. If angle KJL is equal to angle KJM are congruent. For example, if both of them have an angle of 50 and 50 because they both have to be the same. Therefore, there has to be a bisector that cuts it into two equal pieces. JK would be the bisector because it cuts this angle in half. Originally, you could say angle MJL was 100 degrees. Because JK bisects, which is cuts it in half, it becomes 50-50, okay? 9. True statement. Triangle ADM is 180 degrees rotation of triangle CMB. This is that triangle. It flips, okay, or it rotates 180 degrees, right? Which is the same thing as reflection of, in this sense, it's a reflection over the vertical, right? JL. Where's JL? I do not see a JL here. Did I type it wrong? Oops, sorry. Yep. That was a copy and paste from the old question. Okay. Good. Okay. ADM is congruent to, is a rotation of CMD. Good. It rotates, right? That means the side matches up as well as the angles matches up. Hold on. Do you see how I get the angles here? Because these two are vertical angles. That's why it's the same, right? This is the diagonal. Alright, two equal pieces, and this is also the diagonal, cuts two equal pieces. Alright, M is like the midpoint here. Okay, so side, angle, side, that's how you know it's congruent. Also, it's a 180 degree rotation, right? It's a rigid transformation, hence the image is congruent. The triangles are congruent. Alright, next one. This is some constructions, okay? Alright, so the first one. Why do we use a geometric compass when constructing in geometry? The only two things that you can use is a straight edge, which is a ruler, right? But a straight edge has all the numbers stripping off on a ruler, and we have things that make a curve, okay? Those are the most finite geometric objects, which is a line and a curve. Okay, from there we needed tools to construct it. The straight edge gives us our line, and our compass gives us a curve. Okay, if you want like a real definition and you want to look at like the math, you would have to take some advanced topology in terms of geometric manipulation, and you're going to see sort of the need for a curve and a straight edge in terms of its dimensions. Okay, but that's far above it. For this class, just understand that a compass is used to make curves and arcs. Good? Alright, next. You are going to perform the indicated construction. The first one, create a rhombus using the segment. I didn't label it, but you should have here A and B. Alright, let's make our construction. First of all, I have here, and whoop, oh, I need a circle. That's a horrible circle. No fill. That is a horrible one. Let's. Yep, that looks good. Is that a circle? A little bit. Yeah, because you want that as the center. Alright, good. So this would be, let me add more weight to that, and that would make it perfect. Okay, this side would be the radius of this circle. Okay, what you can do then is grab this circle and mirror it right here. Hold on, let me not mirror it yet. Okay, good. That is for this length. Let's make one more. But this time I'm going to make this, what color? I'm going to make this red. And it's going to be for this radius. It's probably going to be a bigger triangle. Good. Right? It would be for this line. This line is going to be red. And the weight for that is going to be bigger. Oops. Okay. From here, right, because you see how a radius can extend here, so you can grab this, bring that hold on. Give me a second. Okay. From here, what can you do? Oh, perfect. I see it. Boom. Bring it right there. Hold. That get because I need to make a line down here. So let me see. Let me see. Hold on. So we have the first curve here and here. Good. Goes down. So we need one more curve. We basically need this here. That means we need a circle that is doing this. Okay. Okay. Then this line goes from there, and that is caused by this second red. Okay. Good. All right. So the two big reds gets us the lines that go right here. Then the blue circles get us our lines going to the left. Okay. Next, construct a line parallel to PR and through the point N. Alright, here's our line, here's this point. Okay, from this line, again, you have to construct circles, so I'm just going to grab the circle from up there, bring it down here. Okay, alright, so, oops, oh, that's easy. I'm just going to extend this to make that the entire diameter. I could make it its radius, but I'm just gonna make it its diameter. Yeah, looks good. Okay. I will see that is now the blue part's diameter. Copy this. Okay. Make that the center. Right? Make this dot the center of this circle. Can I just do that? Hold on. Or am I making some bad assumptions here? That would be a square. Good. Okay. Let me draw. Ooh, I know what I can do. I'm gonna draw a line from here down to the line. So from here to here. Okay. Right. And we would have the first one as your circle. So I'm just gonna make it half of the radius. That's gonna be so much easier. Okay. So whoop. Okay. Let me change that black to black. So the new radius would be right here. Okay. So let's see. This would be its radius. Let me make that a blue color for you. Okay. So if I copy this radius with this circle and bring it up here, right? So that is the center. This will also have the radius, same radius. Okay. If you just extend this line further now, it's not that pretty, but if you extend it a little bit further, let me delete this, right? And delete this. You see, these are parallel lines now. Okay? So you would have to use this radius and these two circles to get it. Okay? Next, you want to construct an equilateral triangle. The equilateral triangle is fairly straightforward. You're mostly using circles again. Okay? Let me bring this down. Alright. Oh, I'm going to make this a little bit smaller to make my life easier, okay? Alright. Just the scale factor, I'm just scaling it down a little bit more. Alright, so I could have the circle very neat, very easier to play with. Good. Yep, perfect. So this is the line that was given, and we drew the circle here. Then from there, we can also do another radius right there. Okay, so that's one. That could be a radius for this circle. Then this, the black line, could also be the radius for the bottom circle. Okay, I could make the bottom circle a different color. Make yourself see it better. Okay, then here you could draw one more circle. Boom. This time I'm gonna make it right. Hold on. Let me draw one radius from here to here first. So, boom, copy here. Right. That I could make. That can make that green. Okay. That green can be coming from the green circle. Good. From the green circle, you could also get one more radius from the green circle from here all the way up there. Okay. There you go. 3 circles will produce your equilateral triangle. Okay. I like scaling it much better. Okay. Each circle gives us 2 radiuses. Then constructed all 3 together will get you your equilateral triangle. Next, let me make this down. Let me scale it down a little bit much better. Alright, construct a hexagon. Very straightforward. Let me grab this right here. Bring it down here. From this circle that we have, and we have the point, what I can do is going from the center, I can construct a radius, right? I can construct multiple radius. Okay. Good. Then from here, so from this point, okay. Right. I can extend that a little. You could have a radius that way. Okay. Oops, sorry. That I can make that the color red. Circle here. And that could be red. Alright. Okay. So, hold on. A hexagon has 7 sides. So curve there. Oops, sorry. That's the curve I want. Hold on. Okay. So we have that radius. Good. Then we want to curve it right here. Okay, we want to make, right, so this is also, that could be the black radius of this black circle or the red of this circle. Okay, it's both. Good. From here, okay, you can start constructing your other radiuses. Okay. Boom. 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 Whoa, it's kind of a little bit off. Okay. Oops. Perfect. Okay. Then we grab another circle, because we'll make that the radius. Try to center it the best as I can. I'll make that. Nope. Let's make that baby blue. Okay. From baby blue, we have that's the radius. Also, we could have one more radius down here for the baby blue. Okay. Boom. That is your baby blue radius. Good. Then continue over. Alright. Go from here. Oops, sorry. Okay, we can make that the purple. And this is going to be And then this is going to be the purple's radius. Is right here. Here. Is it proper? Yeah. Okay. That is going to be the purple's radius. Okay. Then again, apply that again. The intersection's right there. I'm going to make this one orange. Okay. Goes from the center to the outside. Okay, make that orange. Move over. Again, that's the center. Let's make one more radius. Oops. Let's pick a color. We're running out of colors. What about this ugly green? Okay, I'm gonna make that one that ugly green. Okay, that's the radius here. And one more. Bring that up. Center that. And that one I'm gonna make. Nope. No. Ooh, did I make? No. Purple. I already have purple. No. Blood red. Red accent. Yeah, that looks good. Okay. That one will also have a radius right there. Good. So, ready? I'm going to delete. So, this one is the extra one. That's how I get to the outside, okay? I'm just going to delete that one. Then I'm going to delete all their circles, okay? 1, 2, 3, 4, 5, 6. Alright, there you go. That would be your hexagon. Each one of those comes from the radiuses. Ready? I'm going to undo it, right? That's the red radius. Right? That is the radius of that one. So there are 6 sides, so there will be 6 total circles. Each circle produces a radius for the hexagon, right? We just need that extra one to go from the center to the corner. Okay? There you go. That is the construction of the hexagon. Next, construction of a parallelogram. I'm going to scale this a little bit down to make our lives a little bit easier. Alright. First of all, again, you're going to construct a circle. Nope, sorry. Here. No fill. Okay. Goes from this. Nope. A bit smaller. Good. Yep. Yeah, that looks good. Okay. Radius. Then let's grab the bigger one. Okay. I'm going to make that one what? Blue. This one also will have to be blue. The long one is going to be orange. So I'm going to make an orange circle now. And that's going to be my radius. No fill. And the outline is going to be orange. Oh, nope. Perfect. Good. Alright, now all we have to do is extend this to the other side. Boom. From the other side, we can grab this circle. Alright. Okay. Boom. From here. Alright. That can be this circle. You can make it this circle if you want. Yep. And that would be one more. There you go. I have an extra one in here for some reason. Hold on. There should be 2, right? Radius here is for this one. Radius there is for... Whoa. Oh, yep. I have an extra one out here for some reason. Good. There you go. Okay. Two circles with large radiuses for the outside part, then the 2 circles here for the diagonals right there. Okay. Next, bisect the segment. Bisecting, let's just grab one of the pre-made circles. So much easier. Whoops. Let's just bring this down. Pre-made circle. Perfect. Hopefully it matches, right? Good. The first one, try to get this in the center of the circle as much as possible. Good. Then that's going to be this radius. Grab another one. Try to make that the center. Maybe we want to make the circle a little bit bigger. Yep. Yeah, perfect. Likewise, if we go from here, trying to center it as well. Okay, the line that is cut through the middle here where it intersects would be halfway. Okay, so that is the bisecting of the line. So, booyah, I'm going to make that red. And that is going to be weighted that way. There you go. That would be its bisector. You create 2 equal pieces. The 2 equal pieces are the radiuses of the circle. Bisect the angle. Okay. Bisecting the angle. Let's just grab the circle here. Okay. That would be, let's see, hopefully I can get that as the radius. A little bit further. Perfect. Alright, that would be the radius here. Okay. Oh, I don't need the radius. I'm trying to bisect it. Oh, okay. That's easier. So here would be the first one from this first circle. Okay, hold on. Wait. The first one would be like that. Okay, then the second one would be right here. Right. You see the intersecting here? The intersection's right there. So you would draw a ray. Oops, sorry. You would draw a ray from the center to this point that cuts through it. You can make that red. The outline. Okay. You would get 2 equal pieces. Normally, in the book, we see this part. You don't actually see the entire circle. You see the arc. That's where it's coming from. Okay. And yeah, that's it. Alright, that would be all your solutions for the homework. I understand I didn't really explain the construction that well. You have to watch the video where I'm making the shapes. Okay. If you want better explanations, please see me in the class. Alright, this video was kind of a little bit all over the place. I apologize, but I try to go into as much important detail as possible. The said part is the important part. Okay. The chart, not that important. Alright, really not that important. Okay, but understand the translations of the transformations here are very important in terms of its construction. Construction of the geometric objects are also important in terms of seeing where the radius is. Okay, there you go. Those are all the solutions for your 7.5.